Everybody's name's Little One Feather now.
All right, guys, before we get started, are there any questions over the assignment so far? Any questions over the assignment so far? Brendan, face forward. Logan, thank you. All right, guys, so where we stopped yesterday was this problem here. So we started using the square root method, and the first step in the square root method is to get x squared, or the set of parentheses squared, by itself. We want to get x squared, or the set of parentheses squared, by itself first. Now the main way, or main setup that we can use the square root method is going to be if we don't have a middle term, we don't have x to the first power, or the only variable x is inside parentheses squared. If we have one of those two setups, then we can use the square root method. Now for this one here, we don't have x to the first power, we only have x squared, so we can use this method here. Now the first thing we can do is subtract 14 from both sides to get x squared by itself. Because if we subtract 14 from both sides, we'll get that 2/3 x squared is equal to 6. I am. No, I just haven't shaved. Now, is x squared by itself at this point? No. We need to get rid of the 2/3, so we can do what? We can multiply by 3/2 on both sides, which would work, or divide by 2/3. Either one will give us the same thing. Because we can use the calculator. Quit. Figure that out. So we can say 6 over 2/3. And if we do this here, we will get 9. So that tells us that x squared is equal to 9. Yes, sir. Yes. Once we get x squared by itself, we take the square root of both sides. We take the square root of both sides. So when we square root both sides, the square root of x squared becomes x equals. And whenever we square root both sides, we have to add the plus or minus. Now, if x wasn't by itself, we would need to solve for x. Any other questions on this one here? Let's look at the next one. Negative 2x squared plus 1 equals negative 6. Now again, for this one here, we don't have a middle term, so we can use the square root method. So the first thing we need to do is get x squared by itself. So we can subtract 1 from both sides. And if we subtract 1 from both sides, 1 minus 1 is 0, telling us that negative 2x squared is equal to negative 7. Then what can we do next? We can divide both sides by negative 2. It is, or we can leave it as a fraction. Because since we know eventually we're going to take the square root of both sides, it's going to be easier to leave it as a fraction than to try to take the square root of a decimal. Now, is x squared by itself? Yes, so we can square root both sides. Now, the square root of x squared is x is equal to plus or minus. Now, taking the square root of 7/2 does not give us a nice number, but we can use the yellow calculator and plug it in as the square root of 7 over the square root of 2, because what this will do and let us do is rationalize this fraction. Give it to us as the actual answer, because the calculator will tell us that the square root of 7 over the square root of 2 is the square root of 14 over 2. And that'd be our answer. That's it. I can talk about it later. Any questions on any of this here so far? Now, the other arrangement that we could have is if we have a set of parentheses being squared. Now, because x is only inside the parentheses, we can still use the square root method. And the first thing we'll need to do is to get these parentheses here by themselves. So we want to get this set of parentheses by itself. Now, what do we need to do first? All right, guys. So we can still use the square root method on this because the only place where x is inside the parentheses. Now, we need to get them by themselves first. Well, the only thing with the parentheses is the 2 in front of it. Since they're being multiplied, we need to divide both sides by 2, which will tell us that we have x minus 4 squared is equal to negative 5/2. And what do we need to do next? We need to. Here we go. So we'll find out soon enough. So what do we need to do next? We need to square root both sides, yes? So here the square root and square will cancel, telling us that x minus 4 is equal to plus or minus. So we need to find, guys. We need to find out what the square root of negative 5/2 is. So we can say square root of negative 5, guys, over 2. Negative 5/2 does not have a square root. Because again, when we're trying to find a square root, Tyler, guys, we're trying to find out what number times itself gives us this here. So if we're looking at the square root of 9, we're looking at what? 3 times 3. So the square root of 9 is 3. But if we said it was, say, the square root of negative 9, negative 3 times negative 3 is what? 9, positive 9. 3 times 3 is positive 9. So since this is negative, here we have no real solutions. Because if we had graphed this equation, we would have seen a graph that does not cross the x-axis. Any other questions on this here? Okay. We're going to skip to this here, so I'm going to skip those 3 because we've done factoring. We've solved by factoring already. Now, the last thing we're talking about today is finding the zeros of a function. guys? The last thing we're looking at is finding the zeros of a function. And finding the zeros is exactly what we've been doing. Because if I'm trying to find the zeros, I'm trying to find out what value of x is going to make this here be 0. We're trying to find out what value of x that will make this function be 0. Now, if it works out that the zeros of this function are both integers, they're both numbers that don't have a decimal, we could graph this. So we could use the graphing calculator and go y equals 2x squared minus 11x plus 12. And we can hit graph and see if it gives us the two answers. Let's put this down. So we do see that the graph does cross at 2 points, yes? Are both of them integers? Are both of them whole numbers? No. One of them is at 4, but the other is a decimal. We could try approximating it and see, plugging in values, or what we can do is come back over here and factor it. This factoring will work. So we can say 0 is equal to 2x squared minus 11x plus 12. Yes? Okay. So the second one, so this here. So when we're finding the zeros, we're trying to find out what value of x will make it be 0. That's what we're finding. The x-intercepts, the solutions, are all essentially the same thing. We're trying to find out what value of x will make this be 0. So we can set it equal to 0. Now, since graphing didn't give us two answers, two nice answers, two whole number answers, we're going to go on and factor. So when we factor, we look for greatest common factor, but between 2, 11, and 12, there's not a number that goes into all three. There's one that goes into 2 and 12, but since it doesn't go into 11, we can't factor it out. Now we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, they are opposite. Well, here, since it's positive, the signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. When they multiply together, they do, yes. Now we need to find the factors of the first and third term. So we need to find the factors of 2x squared and 12. Well, the factors of 2x squared, we know we'll have x and then we'll have 2 and 1. So there's only one set of factors for 2, so we'll have 2 and 1, and we can plug those in. Now the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which ones do we want to try first? 3 and 4. Now, again, we said there's no greatest common factor to begin with, yes? That also means that in either one of these sets of parentheses, there can't be a common factor. So if we said we use 2 and 6, 2 can go into these here, yes? Anytime we have a common factor, we can factor it out. So I could, if this was a setup, I could pull that 2 out, telling us that we have x minus 1. But if I have a greatest common factor here, it meant there was 1 to begin with. And the reason that this is nice or helpful is that, well, we can say that this setup doesn't work, yes? If I switched the 2 and 6 and said 6 and 2, do we still have a greatest common factor? Well, yes, 2x and 6 have a common factor, which means that 2 and 6, no matter how we put it in there, will always have a common factor, which we cannot have, so we don't need to try those. That takes out one set. If we tried 3 and 4, where can I not put 4 with the 2x? Because 4 and 2x would have a common factor. Yes?
What would be a common factor of 2, 11, and 12? They all goes into it.
And if we pull 1 out of 12, we get, so it doesn't change anything. Now we can check this here. So 2x times negative 4 is negative 8x. Negative 3 times x is negative 3x. Negative 8x minus 3x is negative 11x. Is that the middle term that we wanted? Yes. Which means these two here are multiplied together to equal 0, so one of them must be 0. So we can say 2x minus 3 is equal to 0. X minus 4 is equal to 0. Now we just need to solve these. We need to solve these and find out what the value of x that will make them be 0. Guys, focus. So for the first one here, we can add 3 to both sides, which tells us that 2x is equal to 3. And then we would divide by 2, telling us x is equal to 3/2. So the value of x that we didn't find by graphing was our 3/2. And if we look at the other equation, we can add 4, telling us x is equal to 4. So our two solutions for this are 4 and 3/2. Now if we look back at the graph, well, here we do see that x is 4 where it intersects. And the other spot is 3/2, 1.5. So it does give us those. It's a little hard to tell for sure if that is exactly at 1.5, because it could be similar to 1 2/3, because 1.6 repeated and 1.5 are very close, especially on a graph like this. So it's sometimes good to use that, but also we know that both of those x's are on the positive x-axis, yes? So our solutions should both be positive. It gives us an idea of what the value should be or what we should be looking for. So when we go to factor and we get our answers, if they don't line up with what the graph says, then we know something went wrong and we can go back and check it. Any other questions on any of this here? So we'll look at one last one and then we'll be done for today. And I want to look at 9. So we want to find the zeros for this here, x squared minus 8x, yes? So again, one of the first things we can do is to graph it. X squared minus 8x. So in the graphing calculator, we can hit y equals. Then we'll type the function in, which is x squared minus 8x. Go up and select it. So have it where it's flashing over the top of it. Hit enter. And then scroll back down. Then go on and hit graph and see if it gives you the answers. Now to check those exact values, we can hit second graph, which will give us a table. And again, we're trying to see what value of x will make the y value be 0. And there's 2. Because we have 0 and 8. Because again, we're really wanting to see what value of x will make the y value be 0. So for us here, x is equal to 0, 8. And this here is kind of a nice piece of information to know. Whenever we don't have a constant term, we don't have a term added to it or subtracted from it that doesn't have a variable, one of the solutions has to be 0, because we're trying to see what value of x will make it be 0. Well, if we plug it in here, we'd have 0 squared minus 8 times 0. Well, 0 squared is 8 times 0 is, because if we don't have a constant term like the next one has plus 49, one of the solutions is going to be 0 every time. And I mean, on a problem like this here, both of these do have a greatest common factor of what? X, yes? So we could factor it out which leaves us with x times x minus 8 is equal to, any two things multiplied together that equal 0, one of them must be. So we're saying x is equal to 0 or x minus 8 is 0. X is already by itself. Here we would add 8, so x is equal to, either way it does the same thing. Guys, I'm going to give you the rest of class time to work on this. Part of the assignment is solving these by graphing. So you can go on and use the graphing calculator to solve those and get those done pretty quickly. If you do have any questions, please let me know.